Hey everybody. All right. So we're going to be watching a video, and this is actually on standard number 3. So it goes along with writing the equations and evaluating the equations based on the models and applications that involve exponential models, which are it's a word for a formula that applies to many situations. That's what a model is. So how I'd like you to do this is we should be watching this as a big group, and I'm going to go through an example with you, and then I'm going to ask you to pause the video, and then as a group together, turn around, talk to each other to try a problem that's very similar out of the textbook. It is a problem that is originally in the homework problem set. So it's just making your homework assignment a little bit smaller because we're going to do 3 problems together. I do want you to be talking to each other. I want you to be checking with each other. If you type something into your calculator and you don't get the same answer as everybody else, then you should be nudging someone and saying, hey, help me with my calculator. Because it's your responsibility to make sure that you're typing it in right when you've got a whole group of people that are trying to find the same answer. So just ask somebody. You guys can do this. I know you can. And we're going to go ahead and get started with these examples. So make sure that you've got a calculator and that you've got the formula sheet that I left for the sub to hand out to you. All right, so at the top of the page, there are some definitions of what these different variables represent so that you know where you're inserting information. And there's quite a lot of different variables here, obviously. So the first model that we're going to be looking at is a value increase. That is, something is gaining value. Appreciation is when the value of a product or an item is or a collection of items increases. A coin collection, an antique car, perhaps a very important painting will gain value over time. This is called appreciation. The opposite of appreciation is depreciation, and that's when something goes down in value over time. Technology is an example of something that depreciates. It loses value over time. When you purchase your iPhone, it's worth so much money, but then a year later, it's not worth as much because there's a new product out there. So that's something that depreciated in value. Just an example. Another thing that increases in value is when we talk about interest earned. So interest is something the bank gives you for interest can either be given to you or you have to pay it. But if we're talking about a bank account increasing in value, we're talking about you taking a lump sum of money, putting it in the bank, and letting it sit there, and you will earn interest on that money. So why does the bank give you money for letting you put it, for just putting it in there and letting them hold it? It's because they are then able to loan it out to someone who wants to start a business, buy a car, buy a house, do some improvements, pay for college, whatever it is. So they loan the money out and they charge interest. And what they do in return is they use your money and give you some interest for allowing them to give it to someone else, essentially. So that's when you put money in the bank and you earn interest. So here are the variables. Really quickly, we'll go through them. The V in all of these equations is representing the future value. That is the value after time has passed. What is the account worth now? What is the coin collection worth in the future? Okay, so then we have the P value, and the P is the present value. This is essentially the starting value or the initial value or whatever you're depositing in the bank. So it's the start of the account or the start of the item that you've purchased. Okay, then we've got the N. N is the number of times that you are given interest or that value is added to the account per year. So if you get interest quarterly, as in 4 times a year, that means that they break down the interest. Instead of giving you interest at the end of the year, they would give it to you every 3 months. So you get it 4 times a year. They can do this weekly. You can do it daily. I mean, there's lots of different options. Most banks will do it quarterly or annually, meaning once a year. So N is just the number of times. R is the interest rate or the rate of appreciation if we were using a different form. So the what is the percent that it is increasing? And this is important because if I say 5%, it really means 0.05 as you type it into the formula. If you put an actual 5 in here, you're talking about 500%. So be careful, you do need to use the appropriate decimal. And then t is the number of years in which we're watching this growth occur. So those are the variables. This second formula here is when n equals 1, as in annually. And this is used for when we talk about population increase. We don't count the population increase in an area. Like let's say we're talking about the population of a certain type of bird. You're not going to look at the population every day and count them. You're not going to count the population and look for an increase weekly or quarterly. You're probably going to do it annually. So this would be an increase that would be only once. So n equals 1. If there's no point in putting the n in these positions if the n is 1. So this is a shorter form of the same formula. It's just that n equals 1. So if something happens annually, you can use this formula. So you can add that to your notes there if you want. And then this last formula on this page is called continuously compounded interest. And continuously compounded meaning that they never actually stop to say, at this point we're giving you money. It's just constantly earning value. It's constantly growing. It's continuously compounding. Compounding meaning I'm adding to. And so this is another formula that we use. E is used a lot in nature and in science. Think about cell growth. We don't go like, okay, after 30 seconds this many cells grew, or after 3 days this is how many cells grew. It doesn't. We look at over a period of time, but we don't say on exactly when the clock hits 30 seconds, that's when the new cells appear. That's how interest would work. When May 1st comes around, that's exactly when they give you the money. But that's not how it works for science quite often. It's just a continuous growth. There's no stopping it. So this is kind of that idea here. And we use this formula. And so RT is the interest rate and the time. E is the number E that we've been using for natural logs and for base E. All right, let's get started with some examples. So be ready. Here we go. All right, we're going to find the future value of a certain amount of money that we invested. So I'm going to read it to you. Please read along. Find the future value and interest earned if $1,275 was invested for 6 years at 3.5% compounded monthly. Then find the future value if the same investment was compounded continuously. So we're going to set up two. So on this side, we're going to be using V equals P times 1 plus R over N to the NT. We're using this formula because it's happening monthly in our first scenario. The second one, we're going to be using V equals P E to the RT because it was compounded continuously. So the first thing we want to identify is all of the variables, and are we finding the present value or the future value? In this case, we're finding V. So V is what my goal is. Then I'm going to go down the list of variables. P is 1,275. The interest rate is 3.5%, which I'm going to enter as 0.035. The N is monthly, which means 12 because there's 12 months in a year, and the T is for 6 years. So we're just now going to insert that information into the calculator and then find the value. So I'll give you a moment. Actually, I'll go ahead and write it, and then I'll give you a moment to try that in your calculator. I just wrote that backwards. Let me erase it. So I have 1275 parentheses 1 plus 0.035 over 12 to the 12 times 6. The reason we multiply the 12 times 6 is we're actually looking at how many actual times did you get this money deposited in your account, the interest. And it's not just 6 times because it's 6 years, but it's 12 times each year. So that's where this exponent comes from. So how many times did it actually get invested or added to your account? So go ahead and let's see how this works. I encourage you to make sure that you use parentheses in the exponent. If you don't have the new operating system, make sure you include them in the exponent, and then definitely these large parentheses here. So go ahead and take a moment and try to find that value. I'm going to type it with you, so no need to pause. All right, so I got the value of the account after 6 years to be 1572.46, and I'm rounding like it's money, so there should be 2 decimal places. So $1,572.46. Well, it asked me to find the future value and the interest earned, so I'm just going to subtract the original amount, which was the $1,275. And that tells me that the interest earned was $2,097.46. So if we were to have this particular situation where we were compounding the interest monthly with 3.5% interest for 6 years, that we would have gained almost $300 over 6 years by just allowing our money to sit in the bank. Okay, so let's take a look at the difference of what happens when we actually compound it continuously. So all of my information is exactly the same. I don't have to find it again. I just have to insert it correctly. So in this case, we're using V equals PE to the RT. So I have the present value of 1275. E is the variable, and my exponent is 0.035 times 6 for my 6 years. Again, make sure that as you're entering this, be careful with the exponent, that you've actually made it the entire exponent. And remember, E is located if you press second ln. All right, so when I did this, I got 1572.94. So in this case, if you're comparing, if we were to compound this monthly or compound this continuously, which would mean every minute of every day, you'd be given the interest, that this would be not very much gain. So that's the value. Let's go ahead and subtract the 1275 and see what the difference in interest would be. So the interest in this case, 297.94. So not a whole lot more, just a couple pennies actually in this case. All right, we're going to go ahead and at this point I'd like you to pause the video and I want you to work together on number 63 from page 415. I think this should take you, because it's very similar to the problem we just did. There's one scenario with 2 different interest formulas used, so I really don't think it should take you more than about 3 or 4 minutes. So why don't we go ahead and pause the video. When the class is ready, please unpause the video and resume watching. All right, so for part A, for number 63, I got $13,891.16 would be the present value, and the interest earned was $4,984.62. For part B, I got 13,968 and 24 cents. So that was the current value, future value, I'm sorry. And then the interest earned there was $5,061.70. So this one, there was a little bit more of discrepancy between the two, whether you're using the interest over semi-annually versus using the continuously compounded. All right, we're going to do our next example. Okay, so this time we're going to be finding the present value. In other words, you have this goal of a certain amount of money. So you want to, in this case, find the present value of 30,000 if the interest, so we know the situation. But it's like I have this goal that I want to be able to purchase something with $30,000. So how much do I have to invest today to get my $30,000 in 4 years if I'm compounding it quarterly with 5% interest. So this is more of trying to figure out the goal, kind of a planning idea. All right, so I'm still going to be using the V equals P, 1 plus R over N to the NT power. I'm still using this formula. And this time, my value, because I want to find the present value, that's the P. So that means this $30,000 actually represents the future value, the V, equals P times 1 plus, my interest rate is 0.05. Remember, we're using this 0.05. And I'm compounding it quarterly, which means 4 times. And then it's 4 times 4, 4 for the quarterly and 4 for the number of years that we are watching this grow. So how much do I have to invest today? This should say P, sorry. How much do I invest today to reach this goal of $30,000 4 years from now with this given situation? So we're going to go ahead and first figure out what this mess is right here. That would be our strategy to solve this. Because as soon as I can figure out what this large mess is, by mess I mean this thing, if I can figure out what this is, then I can divide it off to figure out what my present value has to be. Like, what do I have to put in the bank? So take a moment and calculate this 1 plus 0.05 divided by 4 to the 16th power. Figure out what that is, and we can find the present value. So I came up with, and I want you to use the answer in the calculator. I do not round anything. You should be using the calculator answer, but I found that calculator value to be approximately 1. I'm going to write the whole thing out, but you really should be just using the numbers in the calculator. You should never be approximating within a problem. So for accuracy, just divide by the number that's in the calculator. And that's how I'm writing it. It's very mathematically sound, I'm sure. So take the 30,000, divide by this crazy number, and it says that if I want to earn $30,000 in 4 years at this interest rate, then I actually better invest quite a bit. I better just go ahead and put in $24,592.39. So it didn't seem like I could put in $10 and turn it into $30,000 in 4 years. So you really almost are putting in nearly the whole thing. But this would be the amount that we would invest to get to $30,000. So that's the idea of this one. All right, once again, I want you to pause the video and work together. And this time you're going to do number 65, which is on page 416, and you're looking for the present value. So go ahead and pause, and when you're done, let me know what you got. All right, so this one, I found the present value to be $12,984.77. So that's how much you would have to invest over the 11 years to get to your 25,000. So maybe that seems a little bit more reasonable. It's almost like doubling, just a little bit less than doubling your money would take 11 years in this situation. All right, we've got one more example with me, and then some to try on your own. So this time we're going to be talking about decay or half-life. And this is something that the value is going down, so we see a decrease. And the different formulas that you're going to see here are very particular to the problem because they're very scientific. In this case, we're going to find a couple things. And let's read through the problem together. A sample of 500 grams of plutonium-241, which is the name of it. So the 241 is part of the name. So don't think that that's a number that needs to be used. Which decays according to the function defined as follows. T is the time in years. So this is the function that talks about how it decays, how it decreases in size or quantity. Find the amount of the sample remaining after 5 years. Then find the half-life of plutonium-241. So first thing we're going to do is we're going to find out after 5 years. So how much is still there? If there's 500 to start, after 5 years, how much remains? So really we're finding A of t, or A of t, which is 5. So I'm substituting in 5. That's as simple as this goes. But what's this A sub 0? It's the beginning amount. A sub 0 means the initial amount. So whenever you see anything sub-zero, it just means the starting amount. And you'll see that actually next year in your pre-calculus class as well. So it's 500 grams, and I'm multiplying that by E to the negative 0.053 times 5 because I'm substituting in the 5 there. So this is just type it in your calculator and let's see what happens. All right, go ahead and do that. Don't pause because I'll just type with you. All right, so after 5 years, it shows up for me that the amount of plutonium 241 that remains from this original sample is 383.6 grams, and I think that's a good place to round. So 383.6 grams remain after the 5 years. So the next part of the question says to find the half-life. And half-life can be, it shouldn't be confusing. It's saying when do you take an initial amount and only half of it remains. So I'm looking for the time that it takes to cut the amount in half, basically. And this would work if I wanted to cut it into a third. So what I do is I pick an initial amount. So I start with an initial amount. It doesn't matter how much. In fact, I could start with 500. Okay, so like I said, it does not matter how much you choose. So let's say we start with this 500. Okay, it's still e to the negative 0.053, but the variable is in the exponent. Okay, ooh, the variable is the exponent. This should be sending you some solving vibes. You should know where we're headed. Now, if 500 is what I started with, and I'm trying to find the half-life, then I actually already know the afterwards amount. I know that it's going to be 250. And this is why it works with no matter what you start with. If you want to start with 10, then your after amount is 5. If you want to start with 100, then your after amount is 50. If you want to start with 2, then your after amount, your half-life is 1. So it doesn't matter what you start with, as long as these 2 is saying that if I have 500, now I have 250. That's the half-life. Okay, so first step in solving this would be to divide by 500. So I end up with 1/2 equals e to the negative 0.053t. How am I going to solve this? Well, I'm looking for an exponent. So in order to solve this exponent problem, I'm going to use logs. And in this case, because it's a base of e, I'm going to use the natural log. And I'm going to show it to you in a couple steps. The first step is I'm going to write it in log form. That's log base e of 1/2 equals the exponent negative 0.053t. This really means the natural log of 1/2 equals negative 0.053t, because natural log is log base e. And my last step in my calculator would be really to type in the natural log of 1/2 divided by negative 0.053. And this will give me the time it takes to reduce this 500 down to 250. But honestly, it will apply to no matter what the amount is, because the half-life of this particular, I forgot the name of it, this particular chemical, or what is plutonium? You can tell I don't teach science. All right, anyways, find it. Let's type it in. The natural log of 0.5 divided by negative, and make sure you close your parentheses there, guys, negative 0.053. So I'm typing that in, natural log. I use 0.5 instead of 1/2, but it doesn't matter. And it tells me that it takes 13.0, let's go 0.8 years. So this was measured in years. So it takes just over 13 years for this particular 500 grams, or any sample size, right, to decrease to half of its quantity. Alrighty, I think I've talked that one down enough. Alright, so the last one I want you to work on together is page 459, number 5. It's very similar. I think it's just a different plutonium number. I don't, like I said, just try it. And then unpause and we'll check the answer together. Okay, so there were a couple different ones here. The first three were actually asking you just to evaluate and substitute the number in. And then the last one was the half-life. So here we have for A, I got 439.93 grams. Part B was 387.07 grams. C was 263.65 grams. And then D, which where it asked for the half-life of this particular sample is approximately 21.66 years. I'm not so much worried about the rounding. I just want to know that you know how to use the natural log to solve these. So you had to use logs to solve this exponential problem. All right. So moving forward here, I would like you to use the formula sheet to complete the remaining problems. Okay, I encourage you to work together with whatever class time is left, which I have no idea what it is because I'm not there. And these are the problems. This is going to look a little bit different than the list that the sub had for you because I did 3 of those problems in the video. And I didn't make that adjustment when I made my sub plans the other day. So these are the problems that you have left to do. The other ones we did together. So thank you so much for working on these. If we can pause to make sure that everybody gets these problem numbers written down and then go ahead and turn off the video and get to work. You guys are awesome. Have a wonderful weekend and I will see you on Monday.